So our final level of cohesion is going to be that of strong cohesion. So with strong cohesion, we have two sort of categories with us. And these are both the top categories. One of these is not better than the other. It's just we're trying to get both of these within a module. So what we're talking about is overall object cohesion and functional cohesion. Functional cohesion talks about the functions within an object, or if we're not talking about object-oriented languages, something like original just C, not C++, just original C, then we don't have objects to work with. Therefore, we can't get object cohesion, so we only go with functional cohesion. So with these two, you'll notice that they're very specific. It allows us not only to look at a module and instantly know what it does, it also allows us to swap that module out. So for example, in the left side over here with functional cohesion, we have these really defined areas here, and it's when a module supports activities needed for only one problem-related task. And so we have this determine monthly payment rate here. And the thing is that with a proper high cohesion, we could actually take this out. We could take this, we'll say this is the monthly payment, and we could maybe drop in a new module of weekly payment. And it'd be that simple because it's set up in a way where all it's taking in is the proper input data and it's outputting the proper output data. Therefore, if we put in a module that's similar to it but with some things changed, it'll change the whole program really quick and allows us to mix and match our program and sort of customize it a little bit in that way. So with functional cohesion, all we're trying to do is get these modules that are very specific in their tasks, and the functions within the module should do the same. So we don't need a function in the module that does everything, like in sort of a lot of times they'll have like in a init function, and we don't want that init function to just literally do everything within the module. We want some other functions in there. We want to break it up so that even if the init function, even if it's going to go in a sequential order and it is going to call everything in the module, it's not just a giant grouping of code. We have these basically function calls which go to another section of code and does the function, goes to another section, does the function, goes to another section, does the function, and therefore we have this functional cohesion within the module as well. And whenever we build modules like this, we get to the objective. We're finally making it to this point where our program becomes easy to digest and it becomes easy to maintain. And so just another example of that is if, for example, we said to compute intercept of graphs. So, we have just two graphs. And so all we do is we feed it these two graphs of information. So we say we have this graph and this graph. We give it the points, and then it just gives us the point at which they intercept. That's a very specific thing. All it needs is two graphs as input data, and it'll do all the calculations within it and then just output the exact X and Y to get to that point. So again, you can see how that's very narrowed in. And the other one is object cohesion. So this is when all activities only modify a single object. And what we mean by this is, let's say that we have either like a mortgage payment, or we'll go with this, the second one here, the user object. So with the user object, we have basically the object itself. So this is the user. And then at the top here, what we have is a bunch of attributes. So maybe the name, email address, how many times they've logged in, current points if it's like a game system. And then the functions down here are only manipulating these data, these pieces of data. So, you might have something like new user. So this is, new user. And so a new user will initialize all of the data. And then maybe we have getters and setters. So if you can read that, getters and setters, which means they're just something specific to get or set each one of these attributes. And then you could have something like maybe if you do a certain objective, it adds a point to one of these categories. So like, for example, we could do like a login sort of function here. And what that's going to do is it's not reaching out to anywhere else. It's just updating the attributes of the user. So if we log in, we're just going to get ourselves maybe a point in that area or something like that. And so overall, you can see that this is very sort of localized. The user has attributes, and its functions only do very specific things and only update the attributes within the object. And so that gets us that object cohesion. So with functional and object cohesion, we have a problem that is now defined really, really well, and in a way such that it's very easy to mix and match, and there isn't a lot of the spaghetti code of all of this stuff reaching out to everywhere else. We just have basically single inputs from maybe a controller class here telling the user, what it should update. Hey, user logged in, user logged out, user got 50 extra points today, and then it's just going to update all that stuff here. And it doesn't even need to send stuff back, because if we need to see it, we'll just grab the user object and look at the data with a getter from there. But we're trying to create this very small control flow here throughout our entire project, keep it simple, keep it defined, and we have ourselves strong cohesion. Now, on a side note, you'll notice, like I was talking about, if we have really strong coupling, a lot of times we'll have weak cohesion. And the same can be sort of linked here, is if we start, taking a problem and breaking it down into every single function, for example, is a module, we could have really high cohesion, really good functional cohesion. Each one of these does a very specific problem. However, you'll also notice that now these things need to talk to each other. So now we're actually going to start getting this area where these are actually starting to link. Even though the control flow is small, meaning that we're not having 1,000 arrows going each direction, we still have these sort of areas that are just linked together a little bit tighter than you might want. And so in this situation, whenever we get to really, really strong cohesion, a lot of times we can lose our coupling, and our coupling becomes stronger as well. And again, we don't want that. So we're trying to look for that balance between the two. We're trying to come up with a good sort of problem-solving idea here so that we both have strong cohesion and weak coupling.